How does electromagnetic interference, EMI, cause errors? Imagine your electronic device suddenly acting up without any clear reason. Sometimes it's just a glitch, but other times it's a hidden problem called electromagnetic interference. This invisible force can cause all sorts of errors in your hardware and software. Understanding how it works can help you troubleshoot better and keep your systems running smoothly. Electromagnetic interference happens when unwanted electromagnetic signals interfere with the normal signals in electronic devices. These signals can come from natural sources like lightning or static discharges, or from human-made sources such as motors, power lines, or other electronic equipment. When these signals reach your device, they can disrupt the delicate electrical signals that carry data. This disruption can cause the signals to change in ways that make them unreadable or incorrect. For example, the shape or timing of a signal might get distorted. This is called signal distortion and can lead to errors in data processing or communication. Sometimes, the signals become weaker or even disappear, which is known as signal loss or attenuation. When this happens, your device might not detect the data correctly or might not work at all. Electromagnetic interference can also make devices behave unpredictably. They might reset unexpectedly, lock up, or perform actions you didn't intend. Sensors and measurement tools can give false readings because the interference affects their signals. In digital systems, EMI can cause bit errors, which means the data gets corrupted. This can lead to corrupted files or communication failures. In extreme cases, very strong electromagnetic interference can physically damage electronic components. From a troubleshooting point of view, errors caused by electromagnetic interference can look like software bugs. They might appear as random crashes or strange behaviors that are hard to explain. Since the root cause is often in the hardware signals, fixing the software alone won't solve the problem. Sometimes, corrupted data inputs caused by EMI can make software routines fail or act unpredictably. To manage these errors, you can use shielding and grounding techniques. Shielding involves enclosing sensitive parts in conductive materials to block electromagnetic signals. Proper grounding helps divert interference away from critical components. Using filters and decoupling capacitors on power lines can reduce noise and smooth out signals. Good cable management, like twisting wires and shielding cables, also minimizes electromagnetic coupling. Controlling the environment is another key step. Turning off or relocating equipment that generates EMI can help. When troubleshooting, if errors happen randomly or seem inconsistent, testing in an environment with less electromagnetic noise can reveal if EMI is the cause. Using diagnostic tools to detect electromagnetic disturbances can also help identify the source of interference. In summary, electromagnetic interference causes errors by corrupting electrical signals that hardware and software relying on. These errors can look like software bugs but actually stem from environmental electromagnetic disturbances. Recognizing this connection allows you to take steps to reduce EM and improve system reliability. Mastering troubleshooting means understanding both the hardware environment and software behavior, so you can fix issues effectively.